Hello. So this is a recording for a talk I did at YPAC Hackathons a few weeks ago, but the recording wasn't good, so I'm kind of re-recording it now. Uh, okay, so let's get started. So who is this for? So if you have interacted with LLMs and know how to code, but have not built with LLMs yet, this is what I'm going to try to do with this talk, is give you an overview of LLM APIs 101, give you an overview of tools and agents and MCPs, and kind of give you ideas and the foundation to kind of inspire you to hack something cool together on a hackathon, right? Without spending too much time on research yourself. Okay, let's get started. So calling LLM APIs is not that hard. Uh, right here, what I have got is I've installed OpenAI package. And by the way, like all the examples here will be on GitHub in the description. And all the examples are in TypeScript, but if you did the same things in Python, the APIs are very similar. So don't let that discourage you. Okay. So we have OpenAI package, we import it, we create a client. This automatically reads the keys from our .env file, which I'm not going to show, but it's pretty easy to do. And then we call the API to create a completion, right? And we give it two things. First is a system prompt. System prompt is like special kind of prompt, which will tell them know like kind of how to behave. This is made for developers so they can define kind of vibe of an assistant better. And this is like user prompt, which is, okay, hello, I'm Giorgi. Now let's just run this and let's see what this returns. It's not gonna be anything unexpected. I just returns a friendly message. So the thing we're gonna be kind of mock building for this demo is a movie assistant that can help you manage your watch list, right? Okay, so here in the second file, I'll just put the system prompt in a variable so it's easier to read. And I'm still saying, hello, I'm Giorgi. And then after we get an answer to that, then I'm asking the LLM, okay, what's my name? Because I want to test if it can remember stuff, right? So if I run this, one, this is the first completion, which says hello Giorgi, and the second completion, it says it cannot determine my name. And this is the first thing about the LLMs. They're made for completing your text. So it's like you give it some text, this all of this is converted to text, and it gives you back some text as well. And it does not maintain any state. So every request you make needs to have all the context you want to provide to the LLM. So to fix this, the correct solution would be, okay, we call it first time with system prompt and with like our greeting. Then we call it again, but we give the system prompt again, give it the greeting again, we give it back its own message, which in this particular case might not be that useful, but in general, this is something we do. And you can see the role for this is an assistant. This way, like this tells the model it's trained in a way to recognize these roles and know like how to deal with them. And then we ask our question, and if we run this, it's example number 2. Now the LM does remember because we gave it all the context it needed, right? Okay, so after doing this, right, and when it was still the early days of LLMs, people understood that, okay, we can give it text and it can reply, but how do we make it do things, right? Because like we're building an movie uh, geek assistant here, and all it can do is reply with text. But then people realized, okay, JSON is also text. So what if I give another system prompt here where I say you have a tool to search a movie by name and the year and use it when you have to. And then I say important, when you use this tool, respond with a JSON like this. So it's gonna be tool name and tool input, which is like, I guess I should have done like two args, but it is what it is. And then give me name and the year, right? So I extracted like this variable message history. And what I'm doing here is when I'm calling completion, first I add all this previous history and then I add my question, which in this case is who's the director of Goodfellas, right? And after that, after I get that completion, what I try to do is to parse the result and check like if it parses successfully. If it doesn't parse successfully, then we'll okay, I can parse that. If it does, then we check if the tool name is this, and then I get this. But this might still be undefined, so let's try like if this works. Green. Okay, so tool is called and it succeeded. So our approach worked. This is what people did a lot in the early days. But if I go back here and maybe like remove this only, and um, it's probably not gonna return the JSON again. Okay, it actually did succeed. But if I just um, make a typo here, because like these demos are kind of non-deterministic, so I had to like make it fail to demonstrate. But yeah, so in this case, like it kind of added a bunch of wrong stuff here. Even if I didn't do the typo, it would have failed. So this was in general less reliable and harder to maintain because like you usually don't have one tool, you have multiple tools, so you'd have to do all this kind of prompt engineering every time, right? So let's see what the solution is, right? So we removed the second system prompt and we're still asking the same question. Who's the director of this movie, right? But in this time, we'll have this prompt engineering. We define declaratively this tool that's a function that's with the name search movie. It has a description that LLM can understand, and it has the parameters, and each parameter has also description. And then we say, okay, title is required. I have another tool here that is coming, that's gonna come in later. It's add to watch list. It does what you expect it to do. So OpenAI kind of decided this was a good enough feature to have built in. So they kind of trained their models so that they understand this kind of function definitions and they can and the models can at some point decide to reply with tool calls instead of replying with a text message, right? So we have these tools, we have this chat history, we give it. So notice we are also passing the tools here, and let's see what this does. Okay, so as a response, now instead of a content, which was usually text, we get tool calls. And the tool call is search movie, and it has the arguments of title and the year. Okay, this is nice, right? LLM can now tool calls, but now what? Like, how do we process this, and how do we actually search it? Because like the LLM itself can only produce text, right? If it's not an agent, if it's just an LLM, all it can do is provide some text, and then OpenAI kind of parses it in this nice way and gives us these tool calls, right? So okay, so what we're gonna do next is basically the exact same code. We're asking the same question. We're giving it the same search movie and add to watch list tools, and then we do the completion, which is gonna reply something like this. So it's gonna give us the tool calls. Then we uh, do this, right? We check if the reply contains in tool calls. And if it does, first of all, what we do, we update our chat history, right? Because remember from the first example, the LLM is a stateless thing. So you have to remind it like what it did previously on any new request. So we kind of track it that, okay, this was assistant's reply, which was tool calls. Then for each tool call, what we do is we check for the tool call name. If it was search movie, we parse the arguments because it's a JSON string. We pass it to an actual search movie function, which is just an arbitrary function I made up. This could be like calling the API actually, but I just like basically log it and return some dummy data, right? So we call the tool, and the result we JSON stringify it and add it to the chat history, right? Because remember, like it's a stateless thing, so we have to provide it with all the context. And we do the same for it to watch list tool call. And in the end, I'm here just logging this new updated chat history. So let's run this. Run source. Let's paste. And let me enlarge this. Okay, so first of all, you can see that there's this log, which is the same log I have in this function. So you can imagine it's like our code actually called that function, right? So, and this is the updated chat history we got. Okay, so what we see here is this is our initial system prompt. This is our user prompt that we provided. Here what we have is the tool call that we are also tracking in the history that the assistant did a tool call. And here we, at this point, we called our tool actually, got the result and put it here. So you can see all the relevant information here. Our tool will return the title, the year, the director, IMDb score, watch listed, and that kind of stuff, right? Okay, so we have this updated chat history, and the thing I'm going to do in the next example is the exact same code, exact same tools. First, we do like send the question with tools. It probably going to reply with tool calls, and then what I do is with this updated chat history I showed, I call the completion again, right? So let's do that. So this is what we're sending. And let's run example number 6. I have 2 of those for some reason. Okay, so after we send this, right? So here we kind of did 2 steps, right? We made 2 calls. We call it here first. We get the tool call. Then we actually execute the tools. We put those tool results in the history, and then we call it again. And the result is the text that it tells us, okay, the director of Conclave is Edward Berger, which we can verify because that's what we passed, right? Okay, so this is nice, but let's consider this example, right? Here I have modified this uh, question to say, okay, maybe add it to my watch list as well. And this is not deterministic, so I really hope this works. But what I'm expecting this to do is to first ask to first make a tool call to search a movie, and then make a second call to add to watch list, right? So we have this chat history, we have the tools, we call it first time, and then instead of if, I have a while, right? And let's maybe run this first. Or okay, so it worked first of all, my prompt engineering. So what we do here is we first call the LLM with just this message, right? What it replies is it asks us to like it provides this tool call. It says search a movie, and in this loop we do the same stuff. Like we check the tool calls, we execute, the tool, we put it in the history, but before we end the loop, we send that new context. So if you remember from the previous example here, where we first got the tool call and then we also attached the tool call response to the chat history. So we do that and we send it again, right? And we track any reply, then the loop happens, and we get a new tool call at watch list because that was our question. And then we loop again, we check for all the tools, and it happens, right? So we can maybe log here. Oh, not this. Let me just copy this from here. Okay, so this is our initial stuff. It calls tools twice, and yeah. So in this case, like it's so in this example, so this was the previous example, and this is the current one. So in this example, it did just one iteration because it directly called us with two tools, right? So there's an array of two calls. Maybe if I try multiple times, yeah, now it's gonna like it learned. Okay. So what this is missing actually in the end is that maybe we can do one more and log the last completion. Let me find the log for it. Some live coding. Okay, so nice. This time we got separate calls. Okay, so what happened? This is different logs. Let's so in the first loop we got the search movie tool call, and we searched for it. We we added it to the context, send it to LM. Then we looped again. We got add to watch list. We executed it. We added to LM, and here's the all of that. So this is our system prompt. This is our message. This is assistant calling search mode tool. We reply with our answer. Then it asks us to add to watch list. We do that. We add that to the answer, and then we send all of this to LLM, and it responds with, okay, the director is this, and I'll edit this to your watch list. Okay. So the pattern you see here is basically we loop until uh, we don't have any more tool calls and then reply. So usually, like when you have to call LLM with tools and it's also in the loop, people call this agent. So that's like one of the definitions of agent. So if you copy paste this code and run it a bunch of times, then you can say you have developed an agent, which is great. Okay, so, but here, like, as you can see, this is a lot of plumbing, right? I have a bunch of bugs in this code. What if this parse fails? What if this fails? What if, like, in general, something fails? I have no way of retrying this. Also, like, this is really coupled with my LLM provider, OpenAI, and if I needed to do the same thing with, let's say, AI Lab, which is a Georgian LLM provider, then I would have to do like a bunch of code changes to make that happen. So this is where a higher level SDK, which is AI-SDK, comes in, and you can find similar stuff in Python as well. Okay, so what we have here. So we have the same system prompt, we have some chat history, and then here I have a bunch of examples of how AI SDK simplifies stuff, right? So first of all, the thing that we did here, chat, client, chat, completions, create, blah, 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 is now just generate text. and we give it the model, and we give it the chat history. But I can also like swap out the model to be Anthropic, or I can swap out the model to be AI Lab G, which you can easily create like custom provider by providing custom key and a custom base URL, and you can just go to this website and actually talk to them. They have pretty good Georgian embedding models, and their tool calls like here are pretty good. So here we generate text from like 3 different providers, and also what we can do, and you probably, so what you can do is generate object, which is like, okay, I give it a schema using Zod, which is a library which basically lets you define a schema, but also validate it. So it's like kind of 2 things at once. And I give it a schema. It's like object with an array of characters, and inside of the array we have objects which have names and a catchphrase, and I am asking it to list remaining characters and their catchphrases from Goodfellas, right? So if I run this, okay, this is the extracted object, and by now you probably understand that this is based on tool calls. It's like wrapper around tool calls, but actually this is quite handy when you're doing something like you wanna give it some text, let's say a resume from a candidate, and extract like some structured data, right? But these are like normal responses. It's pretty funny that anytime I do this with Claude, I haven't provided any tools here, right? It just chat history, no tools. But Claude literally lies and tells me, okay, I added it to your watch list, so I actually has done nothing. And you can see like yeah, lab also yeah works pretty well with English as well. Cool. So you can use this SDK and it comes with all these benefits. Let's go a bit deeper. So here I'm also going to show you. Okay, so we have the same system prompt, but we went back to that message where we are asking it to look up the director and then kind of watch list it. And this is how you provide the tools, right? So you import this function from AI-SDK tool, and you give it you give it a description that LM can understand. You give it the parameter schema with this Zod library, which where you can also describe stuff. And then you give it execute callback, which is going to be called with the args so that you can actually call your function and return the result. So instead of like that, all that plumbing we did here, where like we defined this as like kind of objects, and then we had to do all this stuff to actually uh, execute the tool calls and give it back and stuff like that. AI-SDK kind of takes care of all of that for you, right? So let me run this. This is, let's minify this. This is 8 example. And so with our prompt, it searched for the movie, it added it to the watch list, and then responded, director of Conclave is Edward Berger. And I also added to your watch list. And then I log these iterations, right? So what is this? So if you remember, like we did this while loop here, and under the hood, this thing does this exact same thing, but you give it like max number of steps. So like if I gave it 4 this time, so it was enough, 4 iterations was enough to resolve my prompt so that there are no more tool calls. So it's gonna loop until there are no more tool calls, but only up to this many iterations. So if I did 1 here, and so let me log the tool call, what we're gonna get is not the nice answer like this, but it's gonna like, we're gonna get back the tool call, which is gonna be executed, and we're gonna not get any proper answer because this was the last response, even though we executed. So in some cases, this might be enough if you just want to react to something. But yeah, we didn't get like this thing fully resolved. Okay, so this is nice, and also like because we are looping here and we're providing tools, this could be considered already an agent, but it's kind of like you don't really know how many steps you're gonna need most of the time. So this is more for like workflows where you have more defined with flow for what's gonna happen in your program. And in more complicated cases, you might want to use something like Mastra, which is an agentic framework. And there are a bunch of other ones like Pydantic, LangChain, Llama Index. These two have both Python and TypeScript SDKs. This one, I think, is just Python. They're all good, but I've chosen to table this one. So what does Mastra give you? So first of all, it has this agent abstraction. So you can easily have like multiple agents, and this framework has like built-in way of these agents communicating with each other. So here I'm defining the movie agent. We give it a name, we give it a system prompt, we give it a model. We can swap it out. It's using that versus SDK. I'm giving it the tools which look quite familiar with the AI-SDK one. It has this additional output schema, which I'm still kind of figuring out how that exactly works, but it's probably very good because LLM could understand better how to compose stuff if it knows both output and input. And you have this execute callback, but it gives you like more, Mastra gives you more context here. Like you also get like runtime context. And in the runtime context, you could have some different agent or some workflow which you call from this agent. So like you can kind of distribute work across different agents. But I'm gonna keep this demo to one agent, but it's not that hard to do. So you give it tools, you give it a memory. So this memory is basically the same thing I did with like chat history, right? I was pushing into this. In production, you definitely don't do that. You probably use some kind of database, but this memory is kind of abstraction on top of that. And then when you actually use this agent, when you initialize this Mushroom framework, um, you actually provide the concrete implementation. So in this case, it uses SQLite, but it's also runs it in memory, but this can easily be Postgres, right? Okay, so yeah, this is how you define it. You give tools and it does all the same stuff. What is also good. So in this directory, I have it set up. You can clone, you can play around with it. Let me run it now. So it gives you multiple things. Most important one to begin with is the playground. But basically, for your agent, it gives you an API you can use in different applications. So when I go to this playground, I have my movie agent here, and let me just copy this so that I don't type too much. Okay, so whoops, I can ask the same question. Who is the director of the movie Goodfellas? When did it come out, right? And it's gonna use this search movie tools, and it gives you this like nice UI to see, okay, this was the arguments passed, this was the result, and then it gives you an answer, right? What I can also do, and I'm gonna not type, just show you the previous thing I did. Then I can ask, can you add it to my playlist, which should have been watch list, but I guess it understands. It's called tool add tool to watch list. Let me zoom in, maybe you don't see. Add to watch list tool. With this argument, this was the response. It replied, and this goes on. I can add to watch list, get watch list, and stuff like that. So you can see your system prompt here. It gives you all these endpoints. So if you want to like integrate this in your different UI, and there are also like frameworks for building your UI. I'm not gonna cover them here, but you can use stuff from Vercel or Copilot Kit. And also there's this really cool thing, traces, where you can let me chat once again. So if I say hello, what's in my watch list? There's probably nothing right now. But okay, let's call it. There's nothing there. And if I go to traces, you can kind of see like the stuff I was logging. Okay, this was the question, this was the answer, this was the tool call, that kind of stuff. You can see like it first kind of like gets its tools, then you can kind of this is kind of a like debugger for uh, your agent. So this was the system prompt, and this was user's prompt, and then it did a bunch of stuff. It did the tool call, and this is like so. Here's the system prompt. This is my message. This is the tool call, and this is the tool result. And somewhere here you can find the response as well. Well, yeah. Okay. So basically, Mastra gives you this like higher level abstractions for building out your agents. And now let's go to, yeah, we talked about Mastra, MCP servers. Okay, so you already should understand tools. And I'm going to show you the definition of MCP, and you should understand like where it kind of fits by now. Okay, so this is the code I have for creating MCP. It's a bunch of plumbing down there, but this is the most important part. I create an MCP server, and then I register a tool. And this tool is check audience rating with a description, with a schema that should be familiar. And then this is the execute function where you just return the result. Here I'm just like, instead of actual calling the API and getting the rating, I'm just returning a random number, but you can put any arbitrary code here. So yeah. And I'm hosting this as a server as I want. And then if I go to my Mastra code, I have this directory here, MCP, where I create an MCP client and I give it a name and I give it an URL, right? So I have this client, and then when I initialize my agent, I import that MCP. So by the way, like the example of Mastra I showed you before is exactly the same, but in just single file instead of like me going different files. But yeah, in this case, okay, so I have this MCP client defined, and in agents, what I do is import MCP and do await get tools. So here are my other tools. This is my MCP tool. So what this does is basically instead of using my kind of local code, right? It just loads those tool definitions over HTTP. Or in theory, like your MCP server could have a different transport as well, right? In this case, I'm using HTTP server transport, but it can be over, let's say, STDIO or anything you wanna implement, kind of. But this is the most popular one. So what is gonna happen, right? Oh, I kind of lost my agent. Okay, so what is going to happen is that when this agent is initialized, it's going to make a request to an MCP server and list, which is going to list all the tools it has, right? It's going to give it the definitions, the descriptions, the schemas. Basically, it's going to return the object very similar to what we had here, where we were manually defining this, right? And then our agent knows it has tools. There's not much of a difference between the local tool and the tool over MCP as far as agent is concerned. Okay, so let me run this. I was actually already running this, so let me restart it. oops, I should do run source 10 MCP server. Okay, so it's running on this URL. And let me also restart Mastra. So as I restarted Mastra, you see it like kind of made a few requests to this to like list all the tools. And let's go back here and let's ask what's the Rotten Tomatoes rating for. Okay, so it should use our so it used our Rotten Tomatoes check audience rating tool. If you look at the console, like there's a bunch of more requests. So it took these arguments, called the tool, got the context, and used it to derive the solution. So as far as agent is concerned, it's like just using tools, right? But it's because like of MCP, it's over HTTPS, so you could host your agent and use like third-party MCPs to provide tools, or just have your own MCP server in a bunch of different places. Also, like nothing is stopping me from using like two different MCP servers. So you can think of MCP as tools over certain exposed over certain transport layer. And that's basically everything I wanted to cover. If you have any comments, please let me know, maybe in the comments. If you have any questions, and all of this code is gonna be available on GitHub. What's next? So there's stuff that I have not covered. Obviously, there's RAG and embeddings. There's UIs. How do you build UIs for this? There's image gen. There's text to speech, and lots of more stuff. But all of this, I hope, gives you a good foundation to kind of get your hands dirty and start implementing some agents. Happy coding, and see you.